Oke, baik. Apakah sudah terlihat? Proyek demo D harus dikumpul kapan? Tanggal 27. Demo D. Ya, tanggal 27. Oke, baik. Selamat malam semuanya. Ini kita lanjut dulu ya, Mbak. Oke, tadi ada yang bertanya mengenai demo D. Ini barusan diupdate hari ini, pukul 18.25 tadi barusan diupdate. Oke, yang mengumpulkan perorangan atau satu grup satu saja untuk pengumpulan proposal satu grup satu saja, baru nanti ada satu lagi form untuk feedback, itu semua peserta harus isi. Oke, jadi udah ditambah untuk template final report ya di mekanismenya. Oke, itu template final reportnya. Nanti pasti diminta linknya, kayak di sini juga ada pengumpulan link untuk videonya. Oke. Nanti dituliskan juga nama norek, lalu apa yang dikerjakan. Oke, baik. Mungkin masih ada yang mau bertanya mengenai final report dan demo D-nya sebelum saya tutup. Baik, kalau Kak, untuk plagiat itu indikatornya apa? Kalau untuk plagiat itu nanti kita lihat dari code-nya. Jadi kayak code lalu untuk proposal gitu. Itu juga kita lihat kesamaannya kayak melalui Turnitin gitu kalau untuk proposal. Tapi kalau untuk code itu akan terlihat sekali kalau ada yang plagiat itu dari penulisannya. Biasa kalau nulis coding itu kan kayak kita nulis ini ya, nulis tangan ya, kayak pasti itu ada yang beda setiap orang. Kayak misal kalau ada yang nulis model itu biasa dia selalu mulai dari akurasinya dulu, matriks apa gitu. Terus tahu-tahu sama persis semuanya sampai penempatan model dan yang lainnya itu kan juga sama gitu. Kadang itu kelihatan jelas sih kalau buat coding. Kelompok yang satu dan yang lainnya bisa sama. Tidak ada perpanjangan waktu, Kak. Kalau sejauh ini nggak ada perpanjangan waktu karena tanggal 1 Juli udah tanggal 30 Juli sudah pengumuman siapa yang lolos buat 20 kelompok yang akan presentasi tanggal 1 besok. Tanggal 29 Juli lah paling enggak, mungkin jam 12 siang. Kalau yang lain udah presentasi lewat yang 10 menit ini kan, udah video presentasi, lalu nanti per tema akan minimal ada satu tim yang akan presentasi langsung. Video presentasinya minimal maksimal 10 menit. Kalau 10 menit itu harus semua yang mengerjakan presentasi ya, jadi mempresentasikan bagian yang mereka kerjakan. Nggak bisa diwakilin satu orang, kalau nanti satu orang kita nilainya, kita taunya yang kerja hanya satu orang. Itu maksudnya 2 Agustus ya, Kak. Hari Senin itu tanggal 1 Agustus. Oke, mungkin ada lagi. Format dokumentasi dan laporan akhir gimana? Ini udah ada ya untuk yang template-nya. Terus format pengumpulan proposalnya PDF. Terus di template sini, di final report template-nya sudah ada untuk dokumentasinya. Ini ya, untuk dokumentasi foto atau screenshot atau bukti lain. Terus kalau screenshot yang atas ini, screenshot dari output modelnya. Kalau pembagiannya tidak sepenuhnya ngoding, apakah boleh? Boleh sih, kalau emang nggak sepenuhnya ngoding. Kayak contoh, mungkin lagi ngerjain kerjaan yang di kantor, terus nggak bisa join buat ngerjain codingnya yang terlalu banyak gitu. Tapi berkontribusi ngerjain proposalnya, mungkin boleh dibagi buat presentasi juga. Mungkin karena udah bikin proposalnya bisa jelasin summary ini projectnya apa, kayak gitu. Itu juga boleh, jadi nggak harus yang presentasi itu demo semua. Kak, kalau video presentasinya hasil gabungan nggak apa-apa, Kak. Jadi masing-masing orang record sendiri, terus nanti jadi satu video. Boleh banget sih kalau mau kayak gitu, karena mungkin nggak ketemu jamnya buat ketemu, jadi boleh kayak gitu juga. Oke, mungkin ada lagi. Apakah ada toleransi untuk satu kelompok hanya berisi 2 peserta saja dibandingkan satu kelompok isi 5 peserta? Nanti pasti ada toleransi saat penilaiannya kok. Kita juga pasti mikirin kalau untuk 2 orang udah selesai seperti apa gitu. Itu pasti ada pertimbangannya nanti. Oke, mungkin ada lagi. Maaf, baru gabung. Template final report ada di mana ya? Oke, bisa dibuka mekanisme demode-nya. Nanti sudah ada nih template-nya di bawah template proposal. Kalau kita ada update untuk mekanisme demode-nya, pasti kita cantumin. Nanti juga diumumin, tadi udah diumumin di Discord juga. Tadi pengumpulan video bebas ya Kak, mau di YouTube or Google Drive. Kalau video ya bebas, tapi lebih mudah kalau di YouTube sih. Jadi bisa langsung tonton tanpa harus download. Atau misalkan pakai Zoom terus cuman record lewat Zoom terus tinggal dibagiin aja link Zoom-nya yang untuk ditonton. Itu juga boleh. Oke, baik. Berhubung ini tadi di awal langsung bahas yang demode-nya, mungkin aku bahas dulu sekalian aja untuk final exam-nya ya. Untuk final exam besok Jumat. Oke, jadi besok Jumat itu jadwal final exam. Oke, jam berapa? Jadi ini ya, final exam dibagi jadi 2. Jadi ada tipe A dan tipe B. Dan ini harus dikerjakan semua. Tipe A itu 50 soal pilihan ganda dan tipe B itu 5 soal coding. Terus bobot final exam itu 20%. Untuk yang tipe A, itu akan ada 50 soal pilihan ganda mulai dari Jumat 29 Juli 2022 jam 19.30 berakhir Senin 1 Agustus 2022 jam 23.59. Terus bobot penilaiannya 25% dari final exam score. Kita menggunakan quizzes untuk final exam-nya. Nah, karena itu kita bikin jadwal untuk bisa ujiannya. Jadi di sini udah ada waktunya, udah ada harinya. Untuk hari Senin ini kita masih pertimbangan untuk ditambah lagi karena ini harusnya kan selesai jam 23.59. Tapi ternyata itu bentrok sama jadwal demode. Presentasi demode di hari Senin. Nanti kemungkinan akan kita update. Jadi kita kumpul, nanti kita kirimin link-nya ini untuk bisa dilihat gitu, link final exam-nya. Terus kalian bebas buat pilih jadwal ujiannya. Cuman ambil ujiannya 1 kali aja, terserah 1 sesi di tanggal berapa dan jam yang mana gitu, itu terserah kalian. Terus setelah itu tipe B itu adalah coding, 5 soal. Nah, mulainya itu Jumat jam 29, tanggal 29 Juli jam 19.30, berakhir di Sabtu 30 Juli jam 19.30, jadi 1 hari. Ini bobot penilaiannya 75% final exam score, berarti 15%. Ini kumpul di classroom, contoh pengumpulannya itu model.h5 dan question.pynp. Jadi modelnya nanti ada 5 model, jadi model 1, 2, 3, 4, 5 berdasarkan soalnya, dan question 1, 2, 3, 4, 5. Itu di zip dalam bentuk nomor registrasi.zip. Kayak gitu. Ini nanti akan ada 5 soal coding. Oke, mungkin ada yang mau bertanya untuk final exam. Oke, pembagian form pengumpulannya Selasa 26 Juli ini pengumpulan untuk yang pengumpulan demo D ya. Itu akan dikumpulkan pembagiannya, kita akan kirim formnya tanggal 26 Juli jam 12 siang. Oke, mungkin ada yang mau bertanya tentang final exam-nya. Oke, tipe A itu nanti setiap 15-10 menit sebelumnya kita kirim linknya. Jadi kalau memang mau ujian naas gitu, kita baru kirim linknya mendekati jam mulai gitu. Untuk tipe B, final exam apa ada jadwal tertentu kayak tipe A? Untuk final exam tipe B nggak ada jadwal tertentu karena ini coding, kita kasih waktu 1 hari untuk ngerjain 5 soal. Jadi kalau udah selesai boleh langsung dikumpul di classroom. Itu bisa diakses info final exam-nya. Bisa nanti kalau udah selesai kelas, aku kasih link buat akses info final exam ini. 26 Juli itu pengumpulan, ini sebentar. Ini untuk form pengumpulan demo D. Project demo. Kalau kemarin dari instruktur lain pada minta di 10 menit. Kalau memang akhirnya bisa di-cut, boleh 15 menit, nggak apa-apa. Oke, mungkin ada lagi. Oke, kalau tidak ada yang bertanya lagi tentang final exam dan final report untuk demo D-nya, ini aku tutup. Mungkin aku tunggu sampai jam 20.03. Mungkin biar lebih gampang yang nyari untuk final exam ini, mungkin nanti aku masukin di mekanisme ya. Mekanisme machine learning yang MLT2 itu. Ada di mekanisme. Kalau untuk bobot yang tugas, kuis, project, final exam itu udah ada di mekanisme semua. Di mekanisme yang ini. Ini ya, untuk bobot penilaiannya. Oke, mungkin ada lagi. Ini udah aku masukin ya untuk final exam yang tadi. Oke, kalau tidak ada yang bertanya lagi nih, saya tutup semua. Oke, kita lanjut ke materi hari ini. Oke, baik. Hari ini materi kita membahas mengenai advanced deployment with TensorFlow. Oke, agenda hari ini kita bahas TensorFlow Extended dan sharing pre-trained model with TensorFlow Hub. Objektif pembelajaran menggunakan TensorFlow Serving untuk melakukan inference di web, terus navigate di TensorFlow Hub, sebuah repositori model yang berguna untuk transfer learning, mengevaluasi cara kerja model, dan membagi metadata model dengan TensorBoard. Lalu yang terakhir, eksplorasi federated learning dan mengetahui cara retrain deploy model sambil menjaga privasi data. Oke, recap minggu lalu kita belajar tentang PCA ya. Minggu lalu materinya cukup berat. Bisa dibilang berat sih, nggak cukup lagi kalau yang PCA itu. Oke, kita next. Oke, minggu ini kita belajar tentang TensorFlow Serving, TensorFlow Hub, terus TensorFlow Board, sama yang tadi Federated Learning. Nah, di sini TensorFlow Serving. TensorFlow Serving adalah bagian dari TFX atau TensorFlow Extended, sebuah API yang membantu klien mengakses model dengan web atau cloud call. Jadi dari data ingestion, data validation, terus ke data transform, baru di model training, model analisis, production model, baru kita model serving. Terus ke prediction-nya, bisa ke PC, bisa ke mobile, seperti itu. Nah, semua klien menggunakan model yang up to date. Jadi, klien 1 model V1, klien 2 model V2, klien 3 model V1 itu kalau tanpa TensorFlow Serving. Jadi, modelnya beda nih. Yang klien 2 udah pakai yang V2, tapi yang lain masih pakai yang V1. Nah, kalau dengan TF Serving, TensorFlow Serving, semuanya nanti akan pakai model yang up to date, yang terbaru. Jadi, udah pakai yang model V2. Terus di sini kita juga bisa pakai load balancer. Klien 1, klien 2, load balancer, jadi TF servingnya model V2. Oke. Bentar, aku coba buat share sound dulu.
Using Flask or Fast API? Are you using Flask or Fast API to serve your machine learning model? Google's TensorFlow team has developed this tool called TF Serving, which is a little better than Flask and Fast API. It allows you to serve model in a better way, and it also allows you to do your model version management in a little better way. So in this video, we'll look into some theory and then we'll practically see how this tool works. Let's begin. Let's say you're building an email classification model where you're specifying whether email is spam or not spam. A typical data science workflow would be you will collect data, do data cleaning, feature engineering, and you will train a model. Let's say this is a TensorFlow model. You will then export it to a file. You can just say model.save, and that will export the model to a file on hard disk. Then you can write a fast API or Flask based server. This is the popular approach. People write these servers which will load the save model, as you can see in this line, and when clients make HTTP call such as this predict function, it will call this function where you use the loaded model. Now let's say this model is running fine in production. You get new data, you train a new model, and you are ready to deploy the next version, which is version 2, to your beta users. So what happens here is version 1 is production, and then version 2 is ready to be deployed to beta users. Now imagine how you would have to change your fast API code in this case. You would somehow detect in your predict function that the given user is a beta user, and then you can call beta model. So see, here I'm loading model 1 and 2 into 2 different variables, and I can serve the request based on what type of user that is. And this is one approach. Maybe you can have a different server altogether just for beta users, but you can already see the complexity here. Here you have to do if else. Maybe you have 5 different versions which you want to serve to different type of users. Overall, you get an idea. The version management is little tedious. TF serving makes this version management easy, and model serving becomes very easy. Here you have to write all this code. We will see in TF serving, you don't have to write any code. You just run one command and your server is ready. So I will show you practically how it looks, but let me mention one another benefit of TF serving. It is batch inference. You might have, let's say, thousands of incoming requests for inference. In TF serving, you can batch those requests and serve those requests to a model in batches. The benefit is better hardware resource utilization. You can have a timeout parameter, say 5 seconds is a timeout, so and your batch size is 100. In 5 seconds, let's say you only receive 52 requests, then it will batch only 52, because you don't want these requests to be waiting till you receive 100 requests, so batching thing also works. Now let me just show you directly how this whole thing works. In one of my videos in deep learning tutorial playlist, I built a text classification model using BERT. So here is the video if you want to see the model building process. But I'm just going to open that same notebook here. And you can see you're classifying email as spam and non-spam using BERT and TensorFlow. Once the model is built and ready, you can export it to a file using .save method. So here I have called .save 3 times basically, just to show you 3 different versions, and you can see these 3 different versions are saved here. So you see saved model directory here. These are essentially the same models, but in real life you would have different models. Version 1 and version 2 would have some differences, but here just for the tutorial purpose I save the same model. So if you go to individual model, you'll see a couple of files, like the assets and the variables and so on. You don't have to worry about what these files are. You can just directly load this model and start using it. The first step here would be to install TensorFlow serving. The most convenient way to install TensorFlow serving is Docker. So you can just pull the Docker image by running this Docker pull command. There are, by the way, other ways, like if you're using Ubuntu, you can do apt-get and things like that. But here, I will just use Docker. Okay, so in my git bash, I can just run docker pull TensorFlow serving, and it will pull the latest image. I already have the latest image, so it's not doing much. But if you run docker desktop, I have Windows, and on Windows I have already installed docker desktop. And if you look at docker desktop, you see I already have TensorFlow serving image on my computer. You can use git clone this. This will just download some sample models for you, but we are going to use our own model. So you can follow these commands just for your own learning. But here I'm going to just load the model which I saved. So I have saved, again, in TF serving I have all these saved models. Okay, so now I'm going to open Windows PowerShell. So you open Windows PowerShell. I already have it open here. I'm just going to call it clear, and okay, it will look like this. And once you have this open, you need to first load the Docker container. So how do you load that? Okay, I have created a GitHub page where I have given all the commands, and I'm going to put the link of this in video description below. But the way you load Docker is by calling this docker run -v. So I will just gradually type in those commands so you get an idea. So you will say docker run. Okay, see there are a couple of command line options. This is not a Docker tutorial, so I'm not gonna go into each option in detail, but -v is an important one. So here you supply your host directory. So I want to use this directory here, right? So I will just say Control C, okay, and Control V. So I want this directory to be mapped to some directory inside my Docker container. So I'll just give the same name, TF serving. So this directory from my host maps to this directory in my Docker image. Then I will do port. So let's say I want 8605 port to be exposed as 8605. So 8605 on my host system is mapped to 8605 on my what? On my Docker container image. And then I will do entry point. Now, if I don't do entry point directly, what's going to happen is Docker will have its default entry point. So the image that we loaded, the default entry point will directly run the tf serving command, but we don't want to do that. So I will just do entry point. Entry point is bin bash. Bin bash will take you to command prompt basically. Okay, and at the end you give the name of your image. So what is the name of your image? Well, it is TensorFlow / survey. When you do that, you will enter into, you see, you have entered into now your Docker image. And within the Docker image, since you map this 48 serving, see 48 TF serving, you see that here. And if you do, let me just clear it. If you do ls, see, if you do ls minus, you see all these directories, you see saved models, which is good. Now, the way you run TensorFlow serving is by running this command. This will run your TensorFlow serving, and here you need to supply your REST API port. So my REST API port where I'll be making my HTTP calls is 8605, and you can have any port pretty much, but we decided 8605. You need to give model name. Let's say anything you can give XYZ. My model name is email model. And what is my model base path? So my model base path is nothing but this directory. Okay, when you run this command, see, in one line we, okay, what is it saying? There is some error happening. Okay, we forgot to give the name of the model file, so it is actually saved models, right? You need to give saved models actually. Okay, so that was the reason I was getting an error. So now this means my model server is ready. See, just by writing one line of code, I created my server. Now, how does this server work? Well, for that, you need to run Postman. So install Postman. It's a popular tool which is used to make HTTP requests. You know what? Before I run Postman, let me just show you in a browser itself. So 8605 is my port. Then you do v1 is just a fixed thing. Okay, v1. Then you do models. Then you do email model. So when I do this, it is saying I have version 3 available, which means by default, when I ran that command, it looked into save model directory, and whatever is the highest number, version 3, it says that is the model which is available. Now I will use Postman to make actual requests. So in the Postman, what you can do is you can say email model :predict. Okay, so I have same URL. Basically, see, this part is kind of fixed. I was confused initially by v1, but ignore that. V1 is always v1. It's not the actual version. Okay, then email model, then :predict. In the body, so by default you'll be here, you have to come to body, and in the body click on raw, and this is the format that it expects. Okay, so let me reduce the font size a little bit. Okay, so here you will say instances, This is a fixed format, okay? Don't ask me why it is like that. That's a format that TF serving expects. And I'm giving two emails. This one is not a spam email. This one is a spam email. And when I say send, so it is sending the request and it got this prediction back. It got this prediction back from the model server that we just started. So here, if the value is less than 0.5, it is not a spam. If it is more than 0.5, it is spam. So you can see, is clearly see, second one is spam, that's why value is more than 0.5. This one is not a spam, hence the value is less than 0.5. If you want to call this by version number, you can simply say slash versions slash 3 colon predict, and you get the same response. But we already saw this has only version 2 of 3 available. If I do version 2 and send, see what happens. It says this model is not found. Even version 1 is not found. So what if I want to make all 3 versions available? I want to make all 3 versions available. Okay, for that you have to use model config file. How do I do that? Okay, let me exit, Control C, it will exit. Okay, I can do that by changing the command a little bit. So here I will say model config file is equal to, so I need to supply model config file. So I already have this config for model.config.a, and if you look at that file, what it says is model version policy all, which means in this directory, whatever version you see, make them all servable instances. So I'm going to run this. See, successfully loaded version 2, version 1, version 3. All 3 should be servable. So now when I say, see version 1 predict, it works. Version 2 predict, it works. I get the same output, by the way, because my models are same. But in real life scenario, version 1, version 2, version 3, they will give little different output. Version 3 works. Version 4, what's gonna happen? Obviously, you don't have version 4, guys. Many times you have a production version. Let's say 1 is a production version. Then you build version 2 and you want to deploy that only to beta users. And you don't want this call to be happening through version. Maybe it will be better if I can do something like, okay, production, like production versus beta. Don't you think that will be better? Well, that's also supported, and in order to do that, you have to use version labels. So I have the same exit file, but I added this section. I'm saying my version 1 is my production, version 2 is my beta, and I'm going to run my model server now with that particular file. So it's a different config file, basically C. Okay, so request to, oh, I see. Okay, you need to, if you get this, okay, let me just show you. Okay, if you give this command, it gives this error, and to tackle this error you need to give this particular option here. If you supply this particular command line option, then you don't get this error. Okay, so now my TF serving is ready. Whenever you see this, it means it is ready, and it can serve using labels. So let's see. So first of all, you can obviously call using version numbers. So let's verify that first. So here I will supply version number 1. It works just okay. But now I want to use labels. So you will just say, instead of version, labels. And let's say beta. See, my beta works. You can also do production. These are the two labels I have. This works just okay. And in your client code, what you'll be doing is, let's say you are making this code in JavaScript. In JavaScript, you'll have all these URLs, prod, beta, whatever. And based on beta or production user, you can switch your user. So this is almost like A/B testing type of scenario where you are testing, new version for beta users. If you look at documentation, model config file has few other options as well. For example, you can serve two entirely different models. You can have a dog and cat classifier here and truck and car cat classifier here. And just by running one command, you can have your server which can do different type of inferences. So just go through this documentation. I did not cover all the options. We talked about batching. So batching configuration can be this. You just pass this batch parameters file, and in the file you can say, okay, batch 128 requests with certain timeout, and it will help you utilize your hardware resources in a most appropriate way. That's all I had for this tutorial. I have a GitHub page where I have given my notebook. You can export the models. I did not upload exported models because they were very big. You have all these config files. So see, this is config.c and so on. I highly encourage that you practice whatever you learned in this video, because just by watching video, you're not going to learn anything. Trust me, you need to practice. So just install TF serving, practice whatever you learned in this video, and I hope you can get a good understanding of how this thing works. If you like this video, please give it a thumbs up and share it with your friends. All the useful.
Oke, tuh ya tadi dijelasin tadi sempat pakai Postman juga, tapi di sini kita coba demo pakai Google Colab. Kita mulai dari yang pertama, TensorFlow Serving yang Hello World. Oke, setup TensorFlow versionnya yang 2. TensorFlow version 2. OS, import. Iya, tadi di video yang akhir ya dibilang jangan cuma nonton video aja, tapi juga harus praktek. Oke, terus di sini tambahin TensorFlow Serving Distribution URL. Boleh loh kalau mau praktek, kalau kelas D itu prakteknya dengan cara pada open Google Colab-nya, terus nanti kalian run-nya ini di Google Colab masing-masing sambil ngetik. Nanti setelah itu di Google Classroom-nya yang di-upload hanya file yang ini, PDF-nya aja dari ini. Jadi nggak bisa nge-run, harus di-kopas dulu di Google Colab kalian masing-masing kalau mau di-run. Kayak gitu, kalau kelas D. Kalau mau kayak gitu boleh lah aku tungguin satu-satu gitu. Tuh tungguin kalau ada yang mau ngetik sambil nyoba. Oke. Oke, kita lanjut aja ya. Kalau gitu. Oke, di sini kita install TensorFlow yang tadi tambahin TensorFlow serving distribution URL. Oke, terus kita install TensorFlow servingnya. Oke, udah done. Kita bikin dataset. Di sini kita XS sama YS. Oke, di sini 0 silent, 1 progress bar, 2 one line per epoch. Untuk verbosity mode-nya. Jadi tadi kalau ini ya kita tambah verbose, kalau 0 itu silent. 1 itu progress bar, 2 itu yang one line per epoch. Kita bikin model sekuensial, 1 layer, unitnya 1, input shape-nya 1. Kita compile pakai SGD, stochastic gradient descent, loss-nya pakai yang MSE, epoch 500, verbose 0. Oke, finish training. Kita print model predict 10. Oke, 18,98. Kita save modelnya di sini. Model underscore dir temp file get temp dir version 1. Oke, already save model version 1 ke 52. Kita save model CLI. Oke, option 3, option 4. Terus kita run si TensorFlow model servernya. Di sini kita launch si TensorFlow model server dengan bash scripting. Sini kita pakai argumen strip bg untuk jalanin scriptnya di background. Terus ini scriptnya itu bakal start running TensorFlow serving dan dia bakal nge-load model kita. Terus di sini ada beberapa parameter yang kita pakai, itu ada REST API port buat kita tahu portnya. Terus model name untuk nanti kita pakai pas kita untuk URL request-nya. Terus model base path. Ini path ke direktorinya ketika kita save model. Ini kita running environment-nya dulu, environment, model dir. Kita jalanin base scripting. Starting job 0, inseparate thread. Sini kita coba lihat server log-nya, kita bisa tahu log-nya. File to run command TensorFlow model. Oke, di sini kita nggak bisa yang bisa jalanin karena search file or no search file or directory. Kita bikin JSON-nya. Oke. Lalu kita bikin inference request pakai yang post. Oke, karena tadi nggak ketemu. model calls-nya error. Karena tadi di atas itu nggak ketemu filenya. Ini ya, no such file or directory. Oke, sebenarnya TF serving ini buat apa ya? Simpelnya kayak biar semua versinya itu bisa up to date terus gitu loh kalau kita deployment. Di waktu nanti kita deployment, kita bisa pakai si TF serving ini biar semua app-nya itu up to date. Jadi misal ada di PC A, B, C, jadi di A, B, C itu semua bisa pakai versi yang baru terus up to date gitu. Nggak nanti yang A versinya masih 1, yang B 2 gitu. Ini biasa kalau yang post itu bisa juga pakai yang tadi ya Postman. Nah, ada yang nggak keinstall kah? File to run. Oke, install from model server, no such file directory. Nah, ini port yang mau dipakai, terus ini nama modelnya, hello. Tadi nama model yang atas, jadi berarti dia nggak mau ketemu sih sama si yang tadi servernya kayak nggak kebaca deh di postnya. Aku juga baru coba sekali ini kalau pakai collab. Jadi biasa kan ada dua ya tipenya yang post sama get. Kalau di sini kita pakai si post. Karena kalau post yang nggak terlihat itu kan nanti lebih dalamnya kalau ke cloud computing ya. Kayak gini request-nya. Di sini karena nggak mau kebaca, jadi dia pas post error karena dia nemuin filenya. Oke lah, yang ini uh, kita tinggal dulu aja deh. Yang ini kalau untuk di collab itu seperti ini, tapi kayaknya ini ada error. Cuma nanti aku cek. Terus kalau tadi kan udah ada contohnya ya, kayak dia beneran buka lewat Postman gitu ya. Nah, biasanya tuh wajarnya dibuka lewat Postman gini sih. Baru dapet gitu. Oke, kita lanjut aja dulu. Live minis. Ya, ini kurang lebih sama kayak yang tadi. Kita import dulu, terus kita pakai datasetnya Fashion Minis. TensorFlow has no attribute logging. Okay. Oke, benar ya. Ternyata kalau untuk di collab itu nggak bisa kita running post di sini. Jadi kalau mau running yang ini kita harus pakai Postman. Barusan dari yang instructor juga bilang kalau yang ini emang nggak bisa, ternyata harus pakai Postman. Oke. Oke, restart dulu runtime-nya. Oke, kita running lagi. Kenapa pakai TensorFlow versi 1? Karena tadi loggingnya ini error. Nah, jadi yang logging ini error, terus diinstalin yang TensorFlow versi 1. Kayak gitu. Oke, udah load datasetnya Vision Minis. Kita bikin modelnya. Oke, optimizer. Adam. Oke. Akurasi 87. Oke, kita save model kita. Oke, kita save modelnya. Terus kita examine si model yang tadi udah kita save. Oke, kita serve modelnya TensorFlow serving. Oke, install TensorFlow serving-nya udah berhasil. Kita run yang TensorFlow serving tadi, kita masukin ke batch scripting, masukin portnya. Oke, kalau untuk yang request yang ini cuman bisanya di, bentar, kalau yang tadi udah ada, oke, mungkin ini bisa. Data, oke, sebentar, data. Oke, ini belum running, kita bikin request untuk model TensorFlow-nya, import JSON data, kita running ulang si data tadi. Oke, berarti masih nggak bisa ya, emang benar ya, berarti itu harus lewat si Postman kayak gitu ya, nggak bisa buat langsung di sini. Oke, jadi kalau mau coba yang ini memang benar harus pakai yang Postman kayak yang tadi di video di hasilnya juga harus lewat yang Postman. Iya, Postman. Oke, kita next. Nggak bisa, harus pakai Postman. Oke, kita lanjut aja ke TensorFlow Hub. Kalau TensorFlow Hub atau tfhub.dev itu library yang buat ini ya, buat ngetes modul desain untuk akurasinya lebih baik. Ya bisa ngetes buat akurasinya lebih bagus gitu, gampang dipakai, terus berintegrasi model kita ke API. Nah, ekosistem dari TensorFlow itu kayak gini, mulai dari training, data design, kita model desain juga, terus kita training, sini distribution strategi, CPU, GPU, TPU, terus analisisnya itu di TensorBoard. Terus kita kalau ke serialization, kita save modelnya, model repository pakai yang TensorFlow Hub. Terus di sini kita baru setelah kita save model, kita deploy-nya bisa lewat cloud, pakai TensorFlow serving kalau cloud, atau Android, iOS, Raspberry Pi itu pakai TensorFlow Lite, kayak yang kemarin kita sempat bahas yang TensorFlow Lite. Terus kalau enggak kita pakai yang browser sama Node, pakai TensorFlow.js. Kita juga udah sempat bahas tentang TensorFlow.js. Jadi itu untuk deployment. Kalau deployment di cloud itu pakai yang tadi ya, TensorFlow serving. Oke, terus di sini publish the module, began, itu inflated 3D, with ResNet, kalau Google itu MobileNet, Inception, NASNet, kalau TensorFlow itu TF-GAN. Masih banyak lagi yang lain modelnya. Nah, transfer learning dengan TF-Hub. Di sini train model dengan data yang kecil gitu, loss data, improve generalization, speed up training. Teks, problem domainnya kalau teks embedding, image itu kita biasa classification, feature vector, augmentation, object detection, generator, style transfer. Kalau video itu classification. Oke, kita lihat TensorFlow Hub.
Anvil is a platform for building full-stack web apps with nothing but Python. Anvil lets you build your app's front end.
Hello everyone, in this video I'll show you something that has been recently released by the TensorFlow team, which is TensorFlow Hub. So without wasting any further time, let's get started. But hey, hold on, it would be really motivating if you can press the subscribe button and also press the bell icon to be notified for amazing videos on data science and machine learning. With that, let's kickstart the video. The issue that I'm planning to discuss next, I'm sure you would have gone through it someday or the other. When you want to apply machine learning to solve a problem, the first requirement that you have is a suitable model. Every day, powerful new models are being published in research papers. Let's say you happen to read about one of them and also find that it is something that fits into your use case really well. The next thing that you want to do is try it out on your custom data set. One of the major challenges that I've discovered at my end is sometimes the model is stored somewhere else. Sometimes there is no good documentation on how you can utilize this model. There are tons of problems that you encounter when you want to use pre-trained models. After you've somehow managed to create a solution using the pre-trained models, you would still have some burning questions at your end. Questions like, how was the model initially trained? Is this the latest version of the model? Is the model fair enough to be utilized in different tasks? So for so many questions, you require answers, and it is here that TF Hub comes into play. So what exactly is TensorFlow Hub? Well, TensorFlow Hub is that place where you can find all the amazing models that are open sourced. You can easily find the latest version of the models, plus the documentation, plus some code accompanying that. So if you have a use case wherein you want to use a model directly with some starter code as well, then TensorFlow Hub is that place. Well, this is the interface for TensorFlow Hub. TensorFlow Hub's rich repository of models cover a wide range of machine learning tasks. For example, in image related tasks, there are models for image classification, object detection, image augmentation, and image generation. When I talk about text related tasks, then essentially we'll have state-of-the-art models like BERT, Albert, and Universal Sentence Encoder that can support a wide range of natural language understanding tasks. There are some video related models as well, such as those for video action recognition, like recognizing gestures in the video. And last but not the least, there are some amazing audio related models as well. So these are the wide variety of models that you directly have access to. In the next part of the video, I'll show you how you can classify landmarks for a particular continent using this amazing pre-trained model that exists on TF Hub. So stay tuned for the next part of the video. I have a small task in hand. I'm planning to visit a new continent and I've seen some amazing landmarks of that continent. I want to get a sense of that landmark name using the images that I've just seen. So it is here that the pre-trained models on TF Hub can come in handy. So Google has open sourced some amazing pre-trained models for different continents. Say for example, I want to travel to Australia. So let me go forward and select this pre-trained model, as this will contain all the amazing landmarks of Australia. So let me go inside. So this is how the web page looks like. You have a pre-trained model which has two versions. You have a TensorFlow version as well as we have a TF Lite version which you can deploy on your Android app. So in order to utilize this model, you just have to go through the entire piece in terms of the README that is supplied with this model. So I have an overview of what this model is about. What are the inputs that the model expects? what are the outputs that the model is going to give out. So I have a label map as well. So this will correspondingly give me a mapping of the number, that is the ID of the landmark, and the name of the landmark. So this is something that I'll utilize in code as well. And I have some example code as well. So essentially everything is given to you. The only piece that you'll have to do is you'll have to replicate the entire process in your system, or maybe Google Colab if you're comfortable using Google Colab. So I'll be basically implementing this landmark detection on Google Colab. So let's move on to the actual implementation piece. We kickstart the activity by importing the necessary modules. So let me run this cell. The first thing that I'll do is I'll add the link of the location of where the TF model exists. So that is what I've done here. The second thing is I'll require a mapping for the IDs along with the name of the location, that is my landmarks in Australia. So that is what I have done here. Both these values exist in the TF hub page that I showed you. So I'll add the link to the URL that I just showed you in the description section of the video. Feel free to explore that link more to get an idea of what I'm doing here. I have an image file with the name image.jpg, which I save into a variable called as img_loc, and adhering to the input requirement of the model, I'll use this image shape to resize my image. So that is, I'll need the image to be 321 cross 321. That is what I've defined in this tuple. So let me go forward and run this cell. Now loading the pre-trained classifier is very simple. All you have to do is you have to define a sequential class. Inside the sequential class, you just have to give reference to the TF hub model. That is what I have done here. There are some additional requirements specifically for this model. That is what I have specified here. The input shape is basically 321, 321, 3, given it accepts colored images. And it gives out an output with an output key equal to predictions : logits. So this is some additional things that I have to add for this model to run. This may or may not be required for the other models that you want to utilize from TF hub. So let me run this cell. So as you can clearly see, I've been able to load the weights of the pre-trained model into the variable called as classifier. The next thing that I'll do is I'll load the CSV file which contains the label map into a data frame called as df. So let me run this cell and let me go forward and show you the first 5 rows of the data frame. So as you can clearly see, ID 0 corresponds to Sydney Cove, ID 2 corresponds to Perth Arena. So these are the different landmarks that exist in Australia. In order to better utilize this label map, I'll convert this data frame into a dictionary. So let me run this cell. So what this dictionary would contain essentially is my IDs would be the key and the values would be the name of the landmarks. Now my overall background work is complete in terms of loading the model as well as loading the label map. The next thing that I'll have to do is I'll have to catch hold of the image. So let me load the image into a variable called as img. Let me also go forward and show you the image.
For just $67, you can make as many videos as you want, and you never need to pick up a camera.
So as you can clearly see, this is a very famous landmark in Australia. So if I'm visiting Australia for the first time and if I want to understand what landmark this is, all I have to do is I have to run predictions on the model that I just downloaded and I'll get the name of this landmark. So I go forward and I do some pre-processing on the image. So let me run this cell. Now that the image has been pre-processed, I am ready to make a prediction. So let me go forward and run this cell. So my result in form of probability scores for various classes have been captured in this result variable. I'll just show you the label map 1 so that you have a sense of what I'm trying to do. So when I say label map 1, that is I'm accessing the first ID in that dictionary and the output is Brisbane River. If this idea is clear, then essentially what I'm doing next is I'll find out the argument, that is I'll find out the ID which has the maximum probability from the result variable, and I'll try to reference it using the dictionary that I've created. So when I run this cell, I'll get the name of the landmark. So as you can clearly see, this landmark is nothing else but Sydney Opera House. So for people in Australia would know this, for people around the globe would also know this, but for someone who is visiting a new continent or a new country altogether, this model can be used really extensively in order to get predictions. The good part about using this model is you can create an Android app and use it directly if you have no internet connection at your end. So this is the power of TF Hub that I wanted to show you. I hope you enjoyed this video. If you like the content that I post on my channel, it would be really motivating if you can press the subscribe.
Oke, kita lanjut. Tadi udah dijelasin juga ya untuk projectnya. Contoh untuk codingnya. Terus tadi juga buka yang TensorFlow Hub itu ya, TensorFlow Hub. Oke, ini ya, TensorFlow Hub.dev. Jadi dia coba untuk yang classification. Di sini ada yang text problem, tuh ada embedding, ada language model, preprocessing, classification. Terus juga ada video. Di sini juga ada audio. Kalau tadi di slide itu belum dimasukin untuk yang audio. Di sini juga ada audio problem. Oke, ini untuk video juga udah banyak, nggak cuma classification, ada generation, ada audio text, ada text. Untuk yang image juga udah banyak banget. Di sini ada add and again juga, pause detection. Untuk yang text problem, oke, kita coba lihat satu. Mungkin yang asik, yang style transfer. Kira-kira ada yang mau request nggak? Kita coba cek yang mana nih. Kita mau lihat yang mana nih. The text, image, audio, video. Kira-kira mau lihat yang mana nih? Audio, text, video. Kita coba yang audio, kita lihat. Speech to text. Wave to vector 2. Overview, dia pakai TensorFlow equivalent of PyTorch. Sini pakai dataset Facebook ya, Facebook. Dia pakai Facebook. Kalau tadi yang wave 2, back 2 yang itu ya, kita coba lihat yang rules. Retrain speech model without any head from Facebook for automatic speech recognition. Oke, ini fine running dulu, terus kita setting dulu, install dulu. Oke, kita session terminate. Terus running. Ini nanti yang lain bisa dieksplor lagi ya, banyak banget bisa dibuka juga collab-nya. Oke, kita model setup TF Hub, pakai TF Hub. First download our model from TF Hub, and we'll wrap our model signature with hub.keras layer to able to use this model like any other keras layer. Fortunately, hub.keras layer can do both in just one line. Oke, kita pakai yang hub.keras layer. Trainable true. You can refer to this script in case you are interested model exporting script. Kita bisa pakai yang script juga. Object pretend layer is the first version of WAV2Vec2 model. This pre-train weight were converted from Hugging Face PyTorch. Okay. Audio Maxlon 246.000, label Maxlonnya 256, batch size-nya 2. Terus di sini in following cell we will work pre-train layer and a dense layer LM head with Keras functional API. Kita setting training state. Okay, model summary. Now we need to define the loss Fn and optimizer to able to train the model. The following cell will do that for us. We will be using the Adam optimizer for simplicity. CTC loss is a common loss type that used for tasks like ASR, where input subpart can be easily aligned with output subparts. You can read more about CTC loss. Okay, kita pakai CTC loss from GSOC WAV2 package. Kita import CTC loss-nya, learning rate 5 pangkat 10 pangkat min 5. Loading dan reprocessing data, di sini kita download dulu datanya, get data dulu, target start XF datanya. Oke, kita pakai dev-clean configuration as this notebook is just for demonstration purpose, so we need small amount of data complete training. Data can be easily downloaded from sini pakai Libir speech ya. Oke, ls data train. Data dir. Sama kita bikin fungsi buat nge-read text filenya. Terus kita import si sound filenya sebagai SF sound file. Terus kita Oke.
P.S. The cards are out for the wedding.
Ini bisa kedengeran nggak ya kalau barusan ini?
P.S. The cards are out for the wedding.
PS, the cards are out for the wedding. Kayak itu teksnya. Terus untuk yang audionya juga sama ya.
P.S. The cards are out for the wedding.
Oke. Sekarang kita combine speech dan text sample and we'll define the function in next cell. The purpose. Okay, sample. Okay, there were no sign of faltering about her full language. Okay, kita bikin fungsi proses text sama proses speech buat yang audionya. Input generator, terus kita setting up datasetnya sekarang. Output signature, buffer size, nyalon reflect filenya, set42, dataset, shuffle, buffer size, sheetnya, sheet. Dataset, kita backdate datasetnya. Dataset, prefetch. Oke, kita training modelnya. Model compile, optimizer, lossnya pakai LSFN. Oke, epochnya 3. Oke, 10 step per epoch. Oke, masih loading epoch ketiga. Loss-nya, loss-nya tinggi. Oke, save directory-nya tadi kita modelnya kita save. Oke, kita udah save. Oke, kita evaluasi, kita pip install dataset tadi. Oke, udah download. Kita bikin. Oke, kita bikin, kita run evaluasi yang tadi, divalidasi data. Okay, dapat hasil. Sini we are using the tokenizer.decode method for decoding our prediction and labels back into the text, and we'll add them to the matrix for where computation after WR. Now let's calculate the matrix value in following cell. Matrix.input. Hasilnya 1. Here's matrix value doesn't make any sense as the model is trained on very small data, and ISR like tasks often require a large amount of data to learn a mapping from speech to text. You should probably train on large data to get some good results. These notebooks give you a template to fine-tune a pre-trained speech model. Inference. Now that we are satisfied with the training process and have safe model in SafeDir, we will see how this model can be used for inference. First, we will load our model using the fkeras model load model. Okay, fine-tune model. Kita load yang tadi save directory. Okay, let's download some speech sample for performing inference. Can replace the following sample with your speech also. Oke, ini kita pakai yang kita udah ada ya GitHub tadi. Now we will read speech sample using soundfile.read and paste it into AudioMax1 to satisfy the model signature. Then we will normalize the speech sample using the WAV2 processor instance and we'll feed it to the model. Import numpy. Tadi kita read, kita pad, habis itu padding, padded. Terus sekarang let's decode number back into text sequence using the WAV2 tokenizer. Okay, 5. This prediction is quite random as the model was never trained on large data in this notebook. As this notebook is not meant for doing complete training, you will get good prediction if you train this model on complete repeat speech dataset. Oke, yang ini ya, yang repeat speech ini tuh besar banget datasetnya. Itu bisa dicoba sih. Jadi cuma contoh. Finally, we have reached an end to this notebook, but it's not an end of learning TensorFlow for speech-related tasks. Oke, ini contoh, ini bisa jadiin template, bisa diubah. Tadi juga ada ya di tulisan di bawah tadi, waktu kita mau download nih sampel, itu bisa diubah juga pakai yang punya kita sendiri. Oke, ini TensorFlow Hub untuk yang tadi audio. Oke, banyak banget yang lainnya. Bisa dilihat juga di sini. Problem domainnya ada 4 di sini. Banyak banget, kita bisa lihat model format yang kita mau apa. Kita bisa tahu versionnya. Oke, arsitekturnya MobileNet, ResNet. Itu juga bisa kita cek. Ini bisa dieksplor nanti, bisa dieksplor sendiri, bisa dicek-cek lagi sendiri, dicoba-coba. Ada GitHub-nya juga, ada file notebook-nya juga, bisa buat template gitu. Oke, kita next. Untuk yang test based model ini aku skip. Karena tadi kita udah coba yang speech itu. Terus yang image classification, itu nanti bisa dicoba ya. Untuk yang image classification, bisa dicoba, bisa dicari sesuai yang kalian mau lihat, kalian penasaran juga mungkin mau coba yang apa nih. Untuk yang image, banyak banget. Ini kalau yang kan tadi kayak udah dijelasin arsitekturnya MobileNet. Ini MobileNet punya Google yang publish. Habis itu tadi ada Nestnet. Terus juga ada yang ini ada Afghan. Jadi kita next ke TensorFlow.
Win it.
Looking at TensorBoard today, it is a tool. We will be looking at TensorBoard today. It is a tool that allows you to debug the issues with neural network. It is also helpful in tracking and visualizing metrics such as loss and accuracy. This is an official TensorFlow a page for TensorBoard, and TensorBoard is a tool that comes with TensorFlow, so you don't have to do a separate installation for it. Now, in the same deep learning series, one of the videos that we had was building a neural network for recognizing handwritten digits. So I'm gonna take the same notebook that we had. So this is the same notebook where you load all this data set, handwritten digits, and then you train it using a neural network. And in this neural network, there was a flattened layer, then there was one hidden layer with 100 neurons, and the third layer had 10 output neurons. 10 is like basically 0 to 9. And we have already done this coding, so if you've not seen that video, please go in this same deep learning series and watch that video, because that video is a prerequisite. So we have done all of this in that previous video, and now we are at a point where we want to look into some of the internals of this neural network. So let me execute this code once again. So if you want to execute all the cells in the Jupyter notebook, you can say run all the cells. So that way I am running all the cells. And here what's happening is I'm running 5 epoch, and with every epoch it is showing me the loss and accuracy for my training data set. Now I came up with this parameters, but you might want to try it with different parameters. For example, instead of Adam, I want to try SGD. Okay, and when you try SGD, you see like here with Adam I get 0.98 in the end, but with SGD you might get a different type of loss and different behavior of your neural network. So here you got 0.92, and we are using very less epochs, only 5, but there might be a case where you might have to run let's say 1000 epoch, and you like reading these numbers might not be that visually appealing. So it will be very nice if we have some kind of visualization or graphical representation which tells you how much your accuracy is going up or your loss is going down per epoch. Okay, so if we had that kind of nice graph, that might be better, and TensorBoard provides that. TensorBoard provides some other functionality as well, but that's one of the functionality that it provides. So let's try it out and see how the whole thing works. So the first thing you need to do is go to the directory. So here I have some old logs file, so I'm just gonna remove it. So this is my current working directory. In here I am going to create a TensorFlow callback. It is a TensorBoard callback. Okay, so this is how it looks. So here is the log directory to save all your logs, and this is your callback. So I will just call it TensorBoard callback, and that you supply in your fit function. So here you will say callbacks is equal to TB callback, And what happens is when TensorFlow is running the training, it will use this callback and it will supply all this information per epoch to TB callback, and that will put that information, or it will log all those events in this logs directory. So in my current working directory where I have this notebook, I will see logs directory, and that will have all the events. Okay, so let's run it once. So in order to run it, let me just run all the cells, so that way we start fresh and we have a clean slate. And I'm running SGD, which is a stochastic gradient descent. This is something we have discussed again in the previous tutorial, so please follow the entire series before you come to this video. Okay, so now it has recorded into TB callback. So how do you exactly visualize it? So for visualization, you can go to the prompt here. I have my git bash, and here you can run this command. So it is saying that run TensorBoard with this logs directory, and you will notice that now I have this logs directory. It has all the logs. Okay, so when you run it, it's gonna run this UI on this particular URL, and you can see here that it launched the TensorBoard. Now the other way of launching this TensorBoard is by using this command. So if you use, for example, if you just want to launch it within Jupyter Notebook, you can launch it like this. So we can try it, and it will render it at the bottom, but it will be similar to what you see here, and I prefer rendering it in a separate browser URL. So here what you're seeing is how your accuracy is increasing per epoch. Okay, so let's see here. So this is training, and this is just smoothing of the curve, and let me just expand it. So at step number 1, my accuracy was 0.9028. You see the 0.9028. So let's see, you see 0.9028, then 0.91, 0.92, 0.9325. So you see all of that. See, this one is 91, 0.92, 0.993, actually 9325, 9325. You see, so these values are matching with the values that you see in this column. Also for loss, we started with 0.8938, went to 0.244455. So here with the loss, you can click here to kind of fit the graph, or you can click here to kind of make it bigger. So let me make this graph bigger, and you will see that we started at some point, then 0.35, 0.3, 0.26, and 0.24. See, 0.2426. So this is just a graphical representation of how your loss is reducing and your accuracy is increasing. Okay, here it timed out, maybe because I have this other thing running, so just I'm not gonna worry about it. I have it running okay here. The other parameters that it has are graphs. So if you look at graphs, by the way, I ran it multiple times, that's why you are seeing multiple graphs, but you can as such you will see only one graph. So let's just do it all over again, because I don't want to see that multiple graph, because those might be confusing. So what I will do is I will stop the execution here. By the way, I'm just running everything from scratch. Okay, and what I will do is I will also stop my Jupyter Notebook, so my kernel is shut down, and I'll just restart it again.
A very strange day is coming to America. In short,
Okay, so restarting this one, and I will say run basically everything. So if you do run all cells, it's gonna just run all the commands from scratch, and I want to see TensorBoard after it has run everything. So once it is done, you can do run this command and it should open up TensorBoard once again. So localhost this, and now when I look at graphs, I see only one graph. So scalars is the same thing that we saw before. Okay, I see multiple charts here. All right, I don't know what's going on with this one, but we'll just go straight to graph. So in the graph, what you see is the inner representation of your neural network. So in the neural network, you will notice that there is 28 by 28 shape for the image that we are feeding. So you saw that in the first network, our input shape was 28 by 28. That was followed by a dense network with 100 neurons, ReLU as activation function. So you will see that if you click on this plus icon, you will see that you got this flattening layer. So when you feed 28 by 28 into flattened layer, it will convert it to 784 like single dimension array, and that is fed into this dense network. And you know, in any neural network, it has, every neuron has two components: weighted sum and then activation function. So weighted sum is matrix multiplication here, and we also add a bias, and then we have ReLU as an activation function. So you'll see 784 was fed here, then there was a matrix multiplication, then there was addition of bias. Again, all this theory we have seen in our previous video, so it should be clear. And then you see dense. Similarly, if you double click here, then you see what's going on in that layer. So in that layer, I had 10 output neurons, activation is sigmoid. So here you will see my activation is sigmoid, output neurons are 10, and again there is matrix multiplication and bias going on. Okay, if you go to histogram chart, histogram will show you the weights. Basically here what you have is bias, and here what you have is kernel, all the weights, and these are each run. We ran 5 epochs, so this is epoch 1, 2, 3, 4, 5, and it is showing the distribution. Histogram you all know, right? Histogram is just a frequency distribution. So it is showing the frequency distribution of all your weights. So for this value you have 49 weights, for example. If you look at bias, for bias you will have dense 1 and dense 4 and dense 5. So let's see, so in the, we have dense 1. So in the dense 1, bias will have 10 output values. So that's what you'll see here. So these kind of visualization helps you debug the issues. Right now our neural network is very simple. In real life scenarios, you'll have much complex neural network, and at that point using TensorFlow can really become handy, and you can debug various things with it. One of the other thing you can do is you can, let's say I tried this with SGD. Now I want to try it with, let's say, Adam. Okay, and when I try it with Adam, I want to do one thing, which is I want to maybe store it in a separate directory. So for Adam, I will just say, let's store that in logs Adam. Okay, and then for SGD, I will just store it in logs SGD. So that way I have like 2 separate directories. So here I will say SGD, SGD. I want to check performance of both the optimizer. I want to see visualization of what these two optimizers are doing. Okay, so then what I can do is just say refresh here, and here it is showing you different runs. Okay, so I'm just gonna uncheck this and check the 2 latest run that I had. You see I had Adam and SGD as a run just recently. So I am unclicking this and comparing these two, and you will notice here how these two are behaving. So my Adam, which is blue, is obviously better than SGD. See, the accuracy is increasing and the loss is also decreasing faster. So this way you can compare two different optimizer or two different hyperparameters. So by the way, here optimizer, matrix, epoch, learning rate, these are called hyperparameters, and the parameters are nothing but the values of weights. Basically the weights and biases are called parameters, and these guys are called hyperparameters because they control those parameters, they affect those parameters. That's why they are called hyperparameters. So I hope this video was useful. You got some understanding of TensorBoard. In the future video, we'll be covering more detailed aspects of TensorBoard. All right. So if you're liking this series so far, give it a thumbs up, share it with your friends. I'm gonna come up with many more tutorials in this series. Thank you for watching.
Oke, tadi ini dikasih contoh gitu ya buat ke TF Board, terus ini coba kita buka TF Board. Gimana tadi? Bentar. Oke, ini untuk TensorBoard. Oke, ini bisa langsung kalau mau di-run ke Google Colab. Oke, ini bisa coba dicek-cek juga kalau mau explore lebih jauh lagi tentang TensorFlow. Ini ada model graph, text data, untuk summarize. Oke, ada hyperparameter tuning, ada embedding projector, TensorBoard in notebook untuk setup, terus juga yang data frame, as data frame. Oke, kita next ke yang fine tuning. Tadi udah lumayan ada coding-codingan tentang fine tuning, tapi belum dibahas ya.
Tired of wasting time?
In this video, I will show you how to use pre-trained models, including how to freeze layers and do fine-tuning. So let's get to it right after this beautiful
Sebentar.
In this video, I will show you how to use pre-trained models, including how to freeze layers and do fine-tuning. So let's get to it right after this beautiful intro. Alright, so the code in front of us right now should hopefully feel very familiar. We've been using these for pretty much all of the videos. except this command right here, TensorFlow Hub. So I'm gonna go into what that is a little bit later in the tutorial. But first of all, if you don't have it, just Google Conda TensorFlow Hub and you'll get to this page. It's also gonna be in the description, and you can download it with this command if you're using Conda. If you're using pip, you're just gonna do pip install TensorFlow Hub. That's it. And so what I want to do in this video is essentially three things. I'm going to first show you if you have a pre-trained model that you've previously trained. So check out my previous video on saving and loading models if you're unfamiliar with that. And then I'm going to show you how to use a pre-trained Keras model. So Keras has a bunch of pre-trained models that you can just easily import. And then lastly, I'm going to show you how to load pre-trained models from TensorFlow Hub. So TensorFlow Hub has a bunch of pre-trained models, and as I said, I'm gonna go into that a little bit later. So first of all, for this for our own pre-trained model, I'm just gonna copy in sort of the data set loading. So the MNIST data set right here, and so we've done this multiple videos, and then I'm just gonna load a pre-trained model. So model is keras.models.load model, and this could be, I mean, if you've trained it. So it's in the pre-trained folder. So so this could be sort of a model that you've trained, or I guess it could be a model that you've found on GitHub or something like that. So you would just load that model, and then you could do print model.summary, and then what you would do is you would check which of the parts you want, right? If you want the entire model, then that's just loading the model, and then you can continue training. But normally when we're doing transfer learning, we're going to pick out a couple of layers. So let's say we want everything except the last one, right? Let's say let's say that this number of classes would be 1000 for ImageNet or something like that. But for MNIST, we would have 10 classes. So then we would have to replace this last dense layer with our own, but we could use sort of the previous layers from that particular model. So how we would do that is we would do sort of base inputs. We would do model.layers. We would take the layer that we want for it to start in, and that's the first one. So we're going to do model layers 0 and then dot input. Then we're going to do base output. And why I'm calling it base is because we're going to use this pre-trained model as our base model, and then we're going to sort of make a layer on top of that one. So what we do here is that we sort of check which, either by just checking sort of 0, 1, 2, 3, 4, 5, 6, 7. So you want the output from the 7th one, or you could count from backwards. So you could do, this is -1 and then -2. So what we're going to do here is we're going to do model.layers, and then -2. And then dot output. So we want the output from this flattened layer right here. In other words, we're removing this layer, the dense last layer. So there are other ways to do this as well. You could also do it with get layer and then sort of take the name. But yeah, we're just going to stick with the index. That's fine. And then we're going to do output. We're going to build our own. So this could be a model, a sequential model or something like that. We're just going to add a single layer. So all we're going to do is layers dense 10 output nodes, and then of base outputs, right? So we're going to first run it through here, and then the output of base outputs is going to be sent into this final output. And then, so I guess we could call it that final outputs. And then we're going to do model equals keras dot, we're going to do, keras.model base inputs. So inputs is equal to base inputs, outputs is equal to final output. And outputs, I guess, because they have multiple. So then we could do print model.summary, and perhaps this should also be called something else than model. So we could call this new model since we've changed the other one. Interestingly, we didn't actually change anything. We just replaced it since the previous model that we had pre-trained, it had this exact layer. But you sort of get the point that you could replace this with whatever you want, with different number of classes and so on. So this is just a sort of a simple example to illustrate how you would actually do it. And so if we now print the new model.summary, we'll, so as I said, we'll get the exact same model, but this one here is now a different one. So if we, for example, would change this to 15, then the sort of the final layer would now have 15 output nodes right here. But of course, we want 10 in this case. And then you would do as normal. So you would, I'm going to copy in the compile and the fit. I don't think it's very relevant. We've seen that in previous videos. So you would just do, in this case, new model.compile and then new model.fit. So we could now run this. All right, so after just a single epoch, we can see that it has over 97% accuracy. And this is only, so this sort of suggests that the pre-training had some effect. Now also, so we can see here that, yeah, after 2 epochs, it has almost 99%. And what you could also do is, let's say that this pre-trained model, you don't want to actually train the entire thing, which, you know, would be the case if you want to do fine-tuning. So what we would have to do is we would have to freeze the layers from this pre-trained model. And how you could do that very simply is do model.trainable, trainable equals false. So that's going to freeze all of the layers. And one other thing you could also do is you could iterate through the layers of the model. So for layer in model.layers, and then you could do, yeah, in this case, we've already set every layer to not be trainable. So we could do something like assert layer.trainable is false. But what you could also do is, if we hadn't done this one-liner right here, for example, if you wanted to just change specific layers, you could also iterate through specific layers, like doing 1 to 5 or something like that. And then you could do layers.trainable is false. Yeah, so just 2 different ways of doing the same thing here. Yeah, so I noticed one error when editing the video. I wrote layers.trainable is false, and yeah, I'm not really sure what that does exactly, but we want to do layer.trainable is false. So that was just a typo right there. For some reason it still ran. I'm not sure what difference it made, but this is what we, what we want to do, and that is already done in this one-liner, so it doesn't really matter. But if you would iterate through the layers, this is how you would do it. The benefit of doing this is if we would now run this, rerun it, and now I don't know if you saw it, but it took about 15 seconds or 16 seconds or something like that to run one epoch. And so if we now run it without, we'll see that it's almost half the actual time. So the benefit of doing this fine-tuning and freezing layers is that it's going to run much faster. And sort of this is I guess the common use case of pre-trained models is that you would take this gigantic model, freeze the layers up to some certain point, and then just add a couple of linear layers at the end for your specific use case. And yeah, so actually we can see here also is that it actually got better performance in this case. Yeah, sort of the same, and that's because these layers that I've imported had already been trained on MNIST previously. So I guess that's one scenario when you're just, you have your own model, or you've loaded your own model. I'm going to remove the code for this right now, and we're going to move on to the next one. So that's if you want to use a pre-trained Keras model. So the Keras library has a lot of models that you can import very easily, and I'm going to show you just a use case of that. And it's going to be very similar to what we did, but using the Keras API for those models. So let's just create some random data just for demonstration to run the model. So we're going to do tf.random.normal, and then shape. We're going to do, let's say 5 examples, 299, 299 by 3. And this is just that it's going to fit the model that we're going to import. So I'll show you in just a second. But those are for the X label, or sort of the features. So they are images of 299 and then 3 channels for RGB. And then we have TF constant, and let's say 0, 1, 2, 3, 4. So 5 classes, and they are all of a different unique class. And then model is keras.applications. And then here there are a bunch of different models you can use. And so I'm going to pick Inception v3. And then there are a bunch of arguments that you can send in here, and you can read more of the official documentations. But one of the most important ones are that you can do this include top equals true or false. And essentially what you can do here is that for the last final fully connected layers, you could remove those and just obtain sort of feature vectors that you can then send into your own sequential model or something like that. So this is probably one of the most important arguments. And we could just do that first of all, and then let's do model.summary just to see what it looks like. Yeah, so what we can see here is that in this case, actually for the Inception v3, there's only a fully connected at the absolute end. So I'm not assuming you're familiar with the Inception module, but essentially it has these concatenations of different convolutional neural networks at this layer, and then it's doing a global average pooling, and then at the end it's doing a fully connected. So if you would do include top false, it would just remove this fully connected layer at the end. But let's say we just want to start with this one. So what we're going to do now is we could do very similar to what we did previously. You could do base input is model.layers 0.input, and then you could do base output is model.layers, and then let's say again we just want to remove the last fully connected. But of course, if it would be several fully connected at the end, you could do -3, -4, sort of removing the exact amount that you want. In this case, we just want to remove the last one, and then dot output, and then we're going to do sort of our last, so we'll do final outputs. Again, we're just doing a single layer, so layers 10s, and then 5 nodes, because we have 5 classes, and then base outputs. So very similar to what we did previously. And then new model is keras.model, inputs equals base inputs, and then outputs equals final outputs. And then again, you would just sort of get the compile. So I'm just going to copy that in just to save some time. So the compile, so we're just using atom, sparse categorical, nothing new. And then we're going to do new model.fit. So let's do new model.fit. X and Y, and then epochs, let's say 15, and then verbose equals 2. And this should be very quick, right? We just have 5 examples, 5 random data points. So let's see if it can overfit 5 data points using this gigantic Inception v3 network. Base inputs is not defined. All right, so base inputs right there. All right, so training on these 15 epochs went pretty quickly, and as we can see, it got 100% accuracy, and the loss is very low. So, but of course, this was just a demonstration of how you would import stuff using this keras.applications models. And so what I want to show you now is how to use the TensorFlow hub. And so TensorFlow hub, essentially, and it's just tfhub.dev. It's essentially where you can get a lot of different models, pre-trained models for different scenarios. So let's say we just want images, then you can sort of, so there's a lot of models here that you can go through and just check. In this case, let's say we want the Inception v3 again. So we can just go to this one right here. And then this is for the feature vector. So this is similarly to the keras one where you could include top equals false. That would give you a feature vector. And that's exactly what this does. So they've separated the Inception v3 for a model that has the top of the fully connected ones, and then one that just returns the feature vector. And then what you do is you just copy the URL. And when you have the URL, and then you can go back to the code. So again, let's do some random data. So let's do tf random normal. Shape is 5,299, 299.3. Sort of exactly what we just did for the loading from the keras. And again, we're loading the exact same model. So this is not going to be anything new, just showing you how to do it with TensorFlow Hub. So then you would do URL equals, and then you would paste the URL right here. And then you would do base model, and then hub equals keras layer, URL, and then input shape 299, 299.3. And then what you would do is you would do model equals Keras sequential, and you would then do the base model, right, which is not including the fully connected layers. And then you could add whatever layers you want. So layers dense, 128 nodes, activation equals, I don't know, relu, layers dense, 64, activation equals relu, and then, yeah, let's do one final layers dense of 10 up, 5 output nodes. We just have 5 classes. And then again, you would do model.compile and model.fit. So I'm just gonna copy those in. And then I guess sort of one thing I missed to do for the Keras model is that, of course, you can do as the first example that we did. So you could do base model.trainable equals false, so that you're doing fine tuning. I should have probably showed that also for the other one, because this is something you can do for all models. And yeah, just for the example, let's try and run this and see what it looks like. All right, so in this scenario, it didn't actually overfit too much, so we would have to probably run it for longer. But as we can see, at least it obtained a 100% accuracy. And yeah, that's pretty much it. Those are the examples I wanted to show you. Sort of different ways you can do pre-training and fine-tuning, freezing layers, and so on. Hopefully this video was useful for you. If you have any questions, then leave them in the comment. And hope to see you in the next video.
Oke, tadi dijelasin ya untuk transferannya, Fine-Tuning, dan TensorFlow Hub. Tadi kita juga sempat buka TensorFlow Hub ya, yang ini. Terus juga tadi untuk yang TensorFlow Board. Oke, tadi juga dijelasin dari awal votingnya ya. Oke, sampai di sini mungkin ada yang mau bertanya. Untuk minggu ini kemungkinan nggak ada assignment ya, nggak ada kuis, nggak ada assignment karena langsung ada final exam. Oke, mungkin ada yang mau bertanya. Jadi minggu ini nggak ada assignment, nggak ada kuis, jadi yang minggu ini langsung final exam. Untuk waktu boleh mengumpulkan assignment-nya yang kemarin mungkin masih belum sempat mengumpulkan assignment-nya. Mungkin besok Rabu aku kasih tahu deadline terakhir pengumpulan assignment-nya kapan gitu ya. Karena masih ditanyakan juga untuk batas terakhir pengumpulan assignment ke tim. Oke, kalau memang nggak ada yang mau bertanya, sekarang udah jam 22.01. Mungkin aku izin buat stop share screen. Oke, jadi minggu depan udah minggu depan berarti jadi besok Rabu itu udah materi terakhir ya. Lalu setelah itu final exam dan minggu depan sudah persiapan untuk certification TensorFlow ya setelah itu. Yang mau ikut untuk kelas persiapan certification TensorFlow boleh banget. Jadi nggak cuman yang 5% aja yang boleh ikut kelas certification itu, preparation. Jadi semua boleh ikut kalau mau nanti akhirnya ambil sertifikasi sendiri itu boleh banget ya. Oke, kalau nggak ada lagi yang mau bertanya, mungkin boleh open cam kita dokumentasi. Oke, aku tunggu sampai jam 22.04 ya. Sertifikasi gratis kan ya, kalau dari yang 5% itu gratis dari Kominfo akan dapat kupon. Untuk yang nilainya 5% teratas, tapi kalau mau ambil sendiri itu $100 bayarnya. Dan sekali beli kupon itu, kalau nggak mau langsung dikerjain, itu ada waktu 6 bulan. Setelah pembelian baru dikerjakan itu masih ada waktu 6 bulan. Baru setelah 6 bulan kalau nggak dipakai kuponnya hangus. Ya, 1 kali attempt. Nah, untuk yang besok ini, final exam yang tipe B itu akan hampir serupa tipe-tipe soalnya untuk yang certification exam. Jadi itu juga bisa buat latihan. Sertifikasi waktu pengerjaannya berapa lama? Kalau untuk sertifikasi TensorFlow itu waktu pengerjaannya 5 jam. Seperti itu. Itu ada 5 kategori soal dan dikerjakan dalam waktu 5 jam. Oke, kita mulai dari layar pertama ya. Oke, layar kedua. Oke. Oke, mungkin masih ada yang mau bertanya? Kalau untuk yang sertifikasi TensorFlow, kalau misal udah ngikutin dari awal sampai akhir, ngikutin code-code-nya, dicoba lagi, di-explore lagi untuk code-nya, itu pasti bisa sih, pasti lulus. Untuk batas lulusnya itu kalau sertifikasi itu di 90%, jadi nilai akhir itu 25, jadi minimal itu 90%, jadi 22,5 poin yang harus dia dapat dari 5 kategori soal. Seperti itu. Oke. Mungkin kalau tidak ada lagi yang bertanya, kita akhiri kelas hari ini. Terima kasih buat teman-teman yang udah pada hadir di pertemuan hari ini. Oke, terima kasih semuanya dan selamat malam.